times 1 plus 2i minus b times 3 plus 4i equals 5. So before you pick out the real bits on the left equal to, the real bits on the right, you need to multiply out. So you get a plus 2ai, I sound like I'm on Geordie Shore now, 2ai, is that what they say in Geordie Shore now? You don't know what Geordie Shore is. Minus 3b, do ye? No. Minus 4bi equals 5. Okay, so I've multiplied everything out. Then you pick out the real bits on the left equal to the real bits on the right. Okay, so real bits have no I in it, so that would be a minus 3b equal to 5. Right, I can't go any further with that. That's it, as far as I can go. Then I pick out the imaginary bits on the left equal to the imaginary bits on the right. So the imaginary bits on the left is 2ai minus 4bi, and there's no imaginary bit on the right, so you just let it equal to 0. Right, there's no imaginary bit over here. Right, divide across by I and you get 2a minus 4b equals 0. Okay, simultaneous equations then. I'm going to multiply the top one by 2 by minus 2. So I go minus 2a plus 6b equals minus 10. And then the bottom one is 2a minus 4b equals 0. They cancel. Minus 2b equals minus 10. So that means b is equal to 5. And then substituting, you'll get minus 2a plus 30 equals minus 10. So that's minus 2a is minus 40. So a is 20. Is that okay? Or have I made a mistake?
Is it not just 2b, not minus 2b?
Yeah, you are right. Yeah, that would be plus 2b. And then that means b would be minus 5. So then that would be minus 30. It's a plus 30 when it comes across. A is 10. Am I right now? No? Still wrong? Minus 5 minus 30. So minus 2a equals... Oh yeah, it's minus 10, is it? Yeah. Okay, great. Alright, is that alright? Okay. 7, 8. Anyone? 8, 9, 10. You need 10. I know you need 10. Right. Okay. So number 10 is z equals the square root of 3 plus 4i. To find z in the form a plus or minus bi, where a and b is an element of R. Right, so they've already said that, so you let z equal to a plus bi equals 3 plus 4i. Now you can't do real equal to real when you've got a square root sign. Okay, so you can't separate the real and the imaginary here because they're both under a square root sign. So you need to get rid of that square root sign. How will I get rid of a square root sign? Square both sides. So you have to square this side and square this side, because you're not able to split up the real and the imaginary when they're all together under a square root sign. Okay, square the first, twice the first by the second. Square the last, b squared, I squared. Is that okay? Equals 3 plus 4i. Everyone with me? Okay. The minute you see an I squared, replace it with a minus 1. Right, so I'm going to replace that with a minus 1. So that's a squared plus 2ab I. That becomes a minus b squared equals 3 plus 4i. Is that okay? Real on the left would be without the i's, a squared plus b squared, sorry, that's minus b squared, isn't it? A squared minus b squared equals 3, right? And the imaginary bit is 2abi equals 4i. Knock out the i's, so you get ab is equal to, divide across by 2, you get 2. And rearrange, so a is equal to 2 over b. Is that okay? Because I'm going to have to put that in there, right? Okay, so so over I come here, a squared minus b squared. Everywhere I see an a, I'm writing in a 2 over b, so it's 2 over b all to be squared minus b squared equals 3. Yeah, okay. Can is it okay if I go like this, or? That's 4 all over b squared minus b squared equals 3. Common denominator b squared, so that's 1 times 4 minus b squared times b squared equals 3b squared. Drop the common denominator, so we have 4 minus b to the power of 4. I'm going to bring over that minus 3b squared equals 0. Right, excuse me. I had b to the power of 4, I'm changing the signs, plus 3b squared minus 4 equals 0. I'm going to do 2 sets of brackets. I'm going to do b squared and b squared. I'm going to do 4 and 1, and I'm going to do a plus and a minus. Okay, so that means b squared is equal to 1. So that means b is equal to plus or minus, sorry, you're gone again. B is equal to plus or minus 1. B squared is equal to 4. So that means b is equal to plus or minus 2. Right, so I have 4 possible answers. B is 1, b is minus 1, b is 2, b is minus 2. Okay, so for each of the 4 answers I have to get an A, right? Okay, so if we have A is equal to, what was it, 2 over B. So when B is 1, A is 2. When B is minus 1, A is minus 2. When B is 2, A is 1. And when B is minus 2, was there any, no, that's fine. A is equal to minus 1. They're my answers. Okay, is that right? Okay, the important thing is there, you couldn't solve it at the start. The reason I wanted to do this for you was because you can't solve it at the start. You can't split it into real and imaginary when it's under each or under a square root sign. You need to get rid of the square root sign first. Okay, yes?
Can you just change the square root sign to, like, to the power of, like, 3 plus 4i or whatever it is, to the power of a half?
And then what are you going to do?
And make it equal to the a plus bi as well, or you have to square root sign.
But then, so you'll get a plus bi equals 3 plus 4i all to the power of a half. Now what you're going to do? What should you do next? Yeah, you see, you still can't separate the 3 and the 4i, because it's not 3 to the power of a half and 4i to the power of a half. It's different, right? Okay, so no, you can't. Right, okay, yeah. Yeah. Okay, right, how am I going? The next bit is really easy. I'm going to do it. It's an Argand diagram, right? Okay, it's really easy. So an An Argand diagram, so is a geometric representation of a complex number as a point. It's basically drawn it on an axis, except we don't have an x and y axis anymore, we have a real and an imaginary axis. So I'll leave you take it down and then I'll show you what it means. It's very easy, it just sounds more complicated than anything. Complex, yeah, plane. Complex plane with real and imaginary axis instead of a Cartesian plane, which is the x and y axis. So we don't have x and y anymore, we have real and imaginary. So a real axis instead of x and imaginary axis instead of y. Right, okay. Yeah, yeah. So an Argand diagram is this drawing. Right, this is what an Argand diagram is. Okay, so if we don't have x and y anymore, we've real and imaginary. Yes. Right, okay. So all it means is to plot 2 plus 3i, that's a complex number. To plot that on an Argand diagram, you go to 2 on the real axis and 3 on the imaginary axis. So it's basically across 2 and up 3. Okay, so this is 2 plus 3i. Minus 1 minus 2i is across to minus 1 on the real axis, down to minus 2 on the imaginary axis. So it will be down there. Right, 4i has no real bit, so the real bit is naught. So 4i, you can write that as 0 plus 4i. So that means across naught on the real axis and up to 4 on the imaginary axis. So this point here is 4i. Okay, and the last one is minus 2, right, there's no imaginary bit, so it's minus 2 plus naught I. So that would be across to minus 2 and up to naught. Got it? Is that okay? That's all I'm doing for today. Easy enough? Yeah? Did you get it? Right, okay. So, on page 15, right, okay, if you do 1 to 3, now question 1 is just straightforward plotting. Question 2 is you have to do the calculations first and then plot the answer. Okay? So question 1, 2 and 3 on page 15, please.